Hey guys, welcome back to Learn Python the Hard Way. Today we're going to focus on exercise 27 and we will be covering logic in Python. Up until now we covered the basics of working with Python, for example how to read and write files to a terminal, and also for example how to do computations and math in Python. But in order to write more complex programs we need to make sure that we understand logic and that we can handle different conditions. So this is the starting point of working with logic. And to get started, we should actually start out by memorizing some of the core concepts when it comes to working with logic. And what the author recommends here is that we actually practice this for an entire week so that we learn the core syntax, the core logic, and then we repeat that every day for like 15 to 30 minutes to really get familiar with that. And of course in the subsequent exercises we will build on top of that and use if conditions, for example, and logical statements to do computations. So in order to memorize new concepts we should just learn a tiny bit at a time throughout the day and then mark down what we already learned. And just to repeat those concepts, we can, for example, use apps such as Anki app to repeat and learn concepts in a spaced out way. And again, if we take 15 to 30 minutes a day, we can work through that and learn that in a good way. All right, so let's get started and let's take a look at the truth terms that we will be using when we work with Python. So in general, a statement can either be true or it can be false. And we have a number of different combinations to figure out if a statement is true or if it's false. And in order to determine that, we can use any of those keywords. For example, AND. So if statement A and statement B, for example, are true, then the entire statement is true. We can use OR to determine if, for example, statement A or statement B is true. If either one of those options is true, then the entire statement will be true. We can use NOT to basically do the reverse. So for example, if not false, for example, then the statement would be true. We can check if two conditions are not equal. And we can also check if they're equal using two equal signs. It's important to use two equal signs as opposed to one, because one equal sign would be the assignment operator. So we would basically do an assignment. If you want to check for equality, we would use two equal signs here. We can check if a statement is larger than another one. We saw an example of that in the previous exercise where we checked, for example, if the number of dogs is larger than the number of humans. And of course, we can also do the reverse to check if a condition is smaller than another one. So for example, if 3 is smaller than or equal to 3, for example. And in general, a statement is either true or it's false. So these are the different keywords that we should memorize when we work with logical statements and when we want to work with Boolean logic. In order to understand that a bit better, we can take a look at different truth tables where we can figure out if a statement is true or if it's not true. So here we can see again not or and, so some of the keywords which we saw before. And we can then see what actually the result would be. If we, for example, say something is not false, then that would be the opposite of false, so it would be true. If something is not true, then it would be the opposite of true, so it would be false. So if we take a look at that in our Python interpreter, we can open our terminal. And then we can open Python here. And if we type in not false, for example, we will get back true. If we type in not true, we will get back false. Instead of using not, we can also use the or operation. So if we are working with or, then if either one of those conditions is true, the entire condition will be true. So for example, if we say true or false, then we can see that true of course is true, false is not true, but since at least one of the statements here is true, the entire condition will return true. The same is of course the case if we check if true or true is true. That is true as well, of course. And that's true for any statements that contains true when we're working with or. So here false or true will also return true. Only if we check false or false, so if any condition here is false, then this will return false instead of true. On the other hand, if we are working with AND, then it will only return true if really any statement, or excuse me, if every statement is true. So in this case, it's basically the reverse of OR. In the case of OR, we always got back true, except for if we had the condition false or false. If we are checking AND here, for example, we will always get back false, except for when we have a true and true. So if we type this in, true and false. Now when we typed out true or false, we got back true, but in this case we will get back false. True and true, of course, will return back true. And then any other statement, for example, false and true, as well as false and false, will return back false. Next, let's take a look at not or. So that's basically the reverse of or here. If you just take a look at the truth table here, in the case of or, the first three conditions here were true and the last one was false. And here in the case of not or, the first three statements are now false and the last one is true. So it's basically just the reverse. And just to take a look at that, for example, with the first statement, if we type out not and then true or false, and we need to use parentheses here just to make sure that the order of operation is correct. If we press enter now, we get back false instead of true. So it's basically just the exact opposite of what we got back from or. And the same is of course the case also with not AND. So if we compare the truth table for AND and for not AND, again they're the exact opposite. So here we have false, true, false, false. And here for not AND it would be true, false, true, true, just because we basically flip from false to true when we use not, or from true to false. And let's just type out the first one. So not true and false. If you take a look at that, true and false would give us back false, because when we use AND, both of those statements need to be true in order for the entire condition to be true. Since in this case we have false in here, this will return back false. But since we have a not in front of it, we will get the opposite back. So instead of false, we will get back true. Next we have not equals. So here we have exclamation mark equals. And by using this condition, we can check if two conditions are actually matching or not matching. So here, for example, we can check if 1 is not equal to 0. That's of course the case, so it's true. If 1 is not equal to 1, 1 of course is equal to 1. So therefore the condition here, 1 is not equal to 1, will return back false. If 0 is not equal to 1, this will be true of course. And then if 0 is not equal to 0, that's false. 0 is equal to 0, so we'll get that back. And of course we can type this out here. Like this. And finally we have equal. So we can check if two conditions are equal to each other. So if 1 is equal to 0, 1 is equal to 1, 0 is equal to 1 or 0 is equal to 0, and that would be the opposite of not equals. So here if we compare, 1 is equal to 0 is of course false, 1 is equal to 1 is true, and 0 is equal to 1 is false, but finally 0 is equal to 0 is of course true. So it's basically the flip side of the not equals operation. And just to take a look at the first term, if we type in 1 equals 0, we will get back false, but if we type in 0 equals 0, of course we will get back true. And then later on we will also learn how we can use that not only for the explicit true or false Boolean value here, or for 1 or 0, but how we can use that with more complex terms to do some more advanced computations in Python. So ideally what we should do is we should write up these tables in separate cards, for example on a piece of paper, or for example in a software such as Enki app, and then we can spend the week to memorize it, so in the future we can use it, and we have it handy, we have it memorized, so we can use it very easily. So let's take a look at some common student questions. Can't I just learn the concepts behind Boolean algebra and not memorize this? Sure, you can do this, but then you'll have to constantly go through the rules for Boolean algebra while you code. So we would basically go back through those rules here. If you memorize these first, it not only builds your memorization skills, but it also makes these operations natural. After that, the concept of Boolean algebra is easy, but do whatever works for you. So ideally we should memorize it just to get familiar with it, and then we have it handy and we can use it very easily going forward. So that's it with exercise 27, and see you guys in the next video with exercise 28.